Avoiding nesting data. Because the Firebase real-time database allows nesting data up to 32 levels deep, you might be tempted to think that this should be the default structure. However, when you fetch data at a location in your database, you also retrieve all of its child nodes. In addition, when you grant someone read or write access at a node in your database, you also grant them access to all data under that node. Therefore, in practice, it is best to keep your data structure as flat as possible. It is best to keep your data structure as flat as possible. So avoid nesting data. Avoid nesting data. All right. Flatten data structures. If the data is instead split into separate paths, also called denormalization, it can be efficiently downloaded in separate calls as it is needed. All right. Create data that scales. When building apps, it is often better to download a subset of a list. This is particularly common. This is particularly common if the list contains thousands of records. When this relationship is static and one-directional, you can simply nest the child objects under the parents. Sometimes this relationship is more dynamic, or it may be necessary to denormalize this data. Many times you can denormalize data by using a query to retrieve a subset of data. However, even this may be insufficient. Consider, for example, a two-way relationship between users and groups. Users can belong to a group, and a group compromises a list of users. When it comes time to decide which groups a user belongs to, things get complicated. Improving our serverless function. Improve by enforcing strongly typed variables and authorization. Create strongly typed variables. Use TypeScript to create models for our incoming request. This will enforce structure in both our code and our request. For example, export interface alert model. Alert string, room number string. Number 2, require that incoming request meet this model to make sure we aren't getting random data in our request or invalid data in our request. Number 3, check the request method before handling the request. We want to look only at post and put request in this case. Get request would be handled differently. Utilize the switch statements we created in Hello World to implement this. So all these 3 steps are improving to our serverless function. Add an authorization piece. Currently, our function is wide open to any and all requests coming through our HTTP endpoint. When a production application, we would not want that to be the case. There are a couple of ways to handle this, one of them being creating an authorization header. So all these improving are really critical when doing a real-time applications, because these are very vital and important, right? And number 2, use the Firebase number two, use the Firebase ID token along with the request and authorization header to verify the request using the Firebase admin SDK. So you need the Firebase ID token, right? And you verify that. This is a good example of implementation at GitHub at. And here's the authorize HTTP endpoint functions. There's a link here. If you click on it, it will open something for you, right? Very important about this step, about the Firebase ID token verification. The code for both these improvements on the project can be found on this link. All right. In the next section, we will use the skills and tools learned from the HTTP trigger to create a separate Google Cloud function triggered by storage event in Firebase. In the next section, we will use the skills and tools we learned with the HTTP trigger that we just finished to create a separate Google Cloud function. Another one, a separate one. This function that we are going to create will be triggered by a storage event, this time by a storage event instead of HTTP trigger, right? In Firebase, in the real-time database that Google has. And this will be the kickoff of this new example, all right? The storage event. In this section, we will continue developing our notification application for hotel guests by incorporating a storage trigger event that sends our storage function into action. We will use the data post from previous exercise as this storage trigger. Once our function is triggered, we will use Twilio again to send off a message, a text message, a short SMS, right, to the customer. Before we get going, we will need to make a couple of changes to our current HTTP function. We want to be able to store the guest's name and phone number in addition to the request and room number. To do this, go back to your function and make sure these fields are of types that can be submitted either by query string or by JSON post body. Once this is done, we can begin creating our function. Create our storage triggered function. This function will be storage triggered, right? As I mentioned earlier, we are developing this application through Firebase to learn something new and to demonstrate different approaches. Unfortunately, we are about to experience one of the pain points of this deployment method, and that is multiple function per project. Multiple functions per project. We will experience multiple functions per project. To be able to handle this change, we are going to restructure our project code a bit. 527 shows the functions folder with our index JavaScript file and additional storage.js file. We are going to place our second function directly in this folder and will handle separate requests within the index.js file. And here is the figure. 527. I will go up again. Here's the first half, and here's the second half, right? The reason we need to include this file directly in our function folder within our HTTP trigger event is because we need to access the HTTP event real-time database. We do not have access to database between projects, so we will deploy the two functions together. Why we are going to deploy the two functions together? Because we cannot access the first function in the first project, so we have to deploy both functions in the second project. Later, we will see an example of how we can deploy all of our functions throughout Google Cloud environment and still have them show up in Firebase as separate entities. To be able to reference the code that we will be using in the storage.js file, we will need to include it in the index.js file. So we need to include the storage.js and the index.js file so we can see it, right? The following code demonstrates how I implemented this, how the author implemented this. And here is the code. Then we can use this variable to call the handler for our storage.js file whenever a new item is written to our real-time database. You can test this by just putting a console.log in your storage file and seeing if it is triggered when the index file is triggered. We'll go ahead and deploy this function to make sure Firebase is recognizing two separate cloud functions. Within the Firebase console, we can navigate to our functions and see the active functions. If it deployed correctly, you will see two separate functions, alerts and send alert. Alerts and send alert. Alerts and send alert. First one is HTTP, the second one is storage. You will also notice different trigger events for each, right? Different events. You should see the right event for the send alert function. So here it says ref.write. We should also make sure the trigger is happening on the appropriate write. We want to be able to track all writes to the alerts table. To do this, we need to reference only alert/push ID. If we wanted to only look at writes specifically related to room numbers, we could do this by referencing to alert push ID/room number. This is something that is good to keep in mind for future iterations. In other words, for enhancement, for getting a better application, right? You could have several functions that read on different keys in the alert JSON tree. Reacting to the triggered event. We want to continue building our application by creating the functionality of the storage triggered. Right now, we have two needs for this function. We have two needs for this function. The first need is send a text to the guest to let them know the request has been received and a service is on its way. Second, update the database to reflect this change and let the function know the alert has been sent out. To handle the text message requirement, we will go back to Twilio account that we created in the last chapter and utilize the service for text messaging. If you didn't set up Twilio account for the Azure chapter, which is the last chapter, please go back and take care of that now. Create a Twilio account, right? We are going to use Firebase environment variables to store the auth token and the account ID. The Firebase SDK for Cloud Functions offers built-in environment configuration and to make it easy to store and retrieve secure data for our project without having to redeploy. To store our Twilio data, we can use the following Firebase commands in our command line to store our Twilio data, right? We can use the following command. To check out our information was stored correctly, we can access the environment variable by using the following Firebase command. And here's to check out that the information is stored correctly. And here's the command. The following demonstrates what this process should look like in your terminal. And here's how it should look like in your terminal. Please deploy your function for the change to take effect after running, and this can be done by typing Firebase space deploy space ---- only functions. All right, now we have set up our environment variables and can use them throughout the storage function. The following code establishes the Twilio client with our two authentication pieces, stores the incoming query string as local variables, create a message using these variables, and send it to the recipient. And this does that. Stores the information in variables, compose the message, and send it. Right? As we can see here, so here we are using Twilio, right? And we provided this account SID and authentication token. And here, all these, like anything is client, is really Twilio. So Twilio sending message here, creating the message, right? We can test this code by deploying it and passing in a query string with the 4 required variables. What are the 4 required variables? They are the from, the to, the body, and I think that's it. What is the 4th one? You have to check. Twilio service, right? The variables are the number, the name, the room, the message. The message to be composed from that, okay. Anyhow, if all goes well, we should receive a text from your Twilio trial account with the message body you provided in figure 5.29. And here is the message that we received, or the author received, by implementing this function. Once we have the texting portion of this function complete, we can go ahead and add the logic to add our real-time database upon syntax message. To do this, we are going to add an alert sent field with a message that describes whether the alert has been sent. And here we go. We will write this return statement at the end of our storage JavaScript file. It sets an alert sent sibling in the alert database and returns a promise. We are setting a sibling so we can keep our alert data structure the same while still providing no information. Let's go through this node. When you perform asynchronous tasks inside Google Cloud Functions with Firebase, they must return a promise. So this is what's the promise. When you perform asynchronous tasks inside Google Cloud Functions with Firebase, they must return a promise. In this case, a promise includes writing to the Firebase real-time database, setting a variable, and the database returns a promise, setting a variable, and the database returns a promise. When we trigger it again, we should now see this a new value in our real-time database. And here we go. Our real-time database has now been updated to reflect the new sibling alert sent. So we have the Firebase open here. console.firebase.google.com. All right. We can also check the status of our function throughout the logging capabilities of Firebase, so we can check it in more than one place. If we navigate to the function tab we will see the logs tab at the top. This will show logs for all functions in the selected project. Sorry, this will show logs, the log files, for all functions in the selected project. The logs will be sorted by time and will be distinguished. We'll distinguish within a console.log statement, function success statements, and errors. So the log is distinguishable. You will also be able to see what function logs are associated with. In figure 531, you can see I have incoming logs for both functions, and one triggers another. You can also view these logs in the Google Cloud Console when we use Google Cloud Project to import into Firebase. Overall, Firebase shares a lot of the same capabilities that Google Cloud environment provides. It is good to get exposure to this because the two environments are very integrated, and going forward, I predict they're being even more integrated. In the next section, we are going to look at the pops up trigger in the Google Cloud Console and learn how to take our Google Cloud projects and view them and execute them using Firebase. This will be in a different video. See you later.